Hi, thank you so much for checking this out. We've got a new blood pressure index based on arterial pulsation. It's just 10 minutes. This is the left common carotid in a patient with severe aortic regurgitation, an 18-year-old male. We can see the pulse is just huge, but it's slowed down so that we can see uh, both the distension and then the retraction. But when you think of it as a pressure wave going by, things get really interesting. But I'm just going to need a better way to map out these distensions and retractions. So we use vascular M mode. We can see that there's a 22% distension and a 14% retraction. Normal's 9%. Over here would be 6%. And this has been shown to indicate severe or moderately severe aortic regurgitation. We can also see some flutter waves here from a mild aortic stenosis. But this raises the question, if the distension changed by 22%, how much did the pressure wave change? Okay, so we can calculate that. The systolic blood pressure minus the diastolic blood pressure divided by the systolic blood pressure times 100, and that equals the systemic pressure change for each beat. And this is a dimensionless blood pressure index, which opens up a whole lot of possibilities. Now, I know you're going to think, oh, well, it's just the pulse pressure. So I took 50 patients, and we'll see those a little bit later. And the systemic pressure change was significantly different from the pulse pressure, 40% versus in the systemic pressure change versus 67 plus or minus 13. So you can see that this measurement has a much smaller variability than this measurement. So why is that? Why is it that this index has less variability than pulse pressure? So we took 50 pediatric patients aged 4 to 17 years with a body surface area ranging from 0.6 to 2.0 meters per meters squared. So this is a lot of kids in a pediatric office, a lot of variability between these children. Some were obese, some were athletes, some tall, some short, 4-year-olds, and what we found was that there's not a lot of variability in carotid distension in this group. 9.3% is what we get for normal, and the range is 4.97 to 13.69. So 22% would be way out of our normal limit. And by the way, that's the mean plus minus 2 standard deviations. Normal carotid retraction was 6.4% plus or minus 2.87, and the range was 0.68 to 13.69, so 14% would be out of the normal as well. And the normal systemic pressure change was 40% plus or minus 6, giving us a range to 27 to 52%. So our patient with the aortic regurgitation had a 60% change, a systemic pressure change, and this is well out of our normal range. So let me give you an example as to why the variability is so much less. We have a 6-year-old, and he has a systemic blood pressure of 100 over 60. That equals 40%. That's normal. And he grows up, and now his blood pressure is 120 over 70, but that's also 40%, so it hasn't changed in all these years. So again, we're looking at a vascular M mode. I've slowed it down from 100 millimeters per second to 25 millimeters per second. And now we can see that it really does look like an invasive pressure tracing here. So here, the distension is 22%. Over here in our normal, the distension is only 9%. So our first patient had 22% distension, and our second patient had a 22% distension. And this seemed very curious. So we have about a 60% pressure change here with a 22% distension, and here we have about a 60% pressure change with a 22% distension, and then a third patient and a fourth patient. So they all seem to have the same values, and we need to explain that. And first I want to make sure that I'm not looking at just some kind of random event here, but they can't all have exactly the same regurgitant fraction. Some will be 55%, some will be 60%, 70%, and yet all these patients seem to have exactly the same amount of distension. So to answer this question, I retrieved the blood pressures on these four patients up to 10 years of blood pressure recordings. So let's see what that had to show us. So in our retrieved systemic blood pressures, in 4 patients with severe AR, the systemic pressure change was a better indicator of severe aortic regurgitation. So 98% of these blood pressures were about 60%. So it was a better predictor than pulse pressure, which was only 72% of those values were abnormal when compared to our control group. Diastolic pressure was low in 51% of these patients. So this was not a good indicator of severe aortic regurgitation at all. So among 48 blood pressure measurements that we made over a period of 10 years. So let's have a look at those blood pressures. Okay, so the systemic pressure change in severe AR in these 4 patients was remarkably similar, both on the day that we record them and historically. So they've been the same for many, many years. So not a statistical variation. They've been like this for many, many years. So my explanation for this is why are they the same is the law of diminishing returns. You could go bigger, you could get higher pressure changes and bigger diameter changes, but it just wouldn't be practical. So it's not practical to have a 30% distension in your left common carotid. Even if you have a very high regurgitant fraction, you wouldn't be able to sleep, it would be painful, and you'd also put a lot of wear and tear on the heart. So here is the graph of a patient with severe aortic regurgitation. He had a balloon procedure as a neonate, and around 4 years old, he crosses the line. Probably the ventricle has been remodeled now, and he maintains this about 60% pressure change. So this is our 95% confidence limit, the mean plus or minus 2 standard deviations, based on our control group of 50 pediatric patients. So you may not be convinced by just 4 patients how this works. So I went to the Academy of Pediatrics blood pressure tables and did about 100 calculations, and I'm able to see normals and patients with hypertension. And they're very close to the values that we got in our lab, running about 40%. So in the early stages, we can see this decline in blood pressure to around 5 or 6 years, and this is a transitional period where systemic vascular resistance and pressure are dropping. And the reason for this is a fetus has to have a pressure that is in a resistance that is in tune with the placenta, which becomes more and has more and more resistance as the pregnancy progresses. And it's not until this age when we start seeing normal values. In this period here from 6 to 11 years, we get some fluctuations here, actually dropping below our 40%. But in boys, it becomes very, very steady here at 42%, and this one is in girls, it's hovering around 40%. So my question is, how far does this line go? Probably till around 50 or 60, when it's going to start to go back up again, probably to this level. So in patients with hypertension, and the Academy of Pediatrics defines hypertension as the 95th percentile plus 12, we can see that boys start off a little bit higher than girls, and we come down to this point here. Again, we can see almost identical between boys and girls for many years in those with hypertension. And finally, we're going to come up to what's our baseline level here, about 33% and about 34% in boys. And it looks like this value will keep going for many, many years. So if we superimpose a patient with aortic regurgitation onto this graph, we can see that the blood pressure goes well above our 52% confidence limit and stays elevated. And if we look at a patient with a moderate aortic stenosis, we can see that there's a tendency for this to fall. So here we get a bounding pulse, and here we get a blunted pulse. So it makes sense to me. So in conclusion, both the systemic pressure change and carotid pulsation are proposed indicators of severe aortic regurgitation. And retrieval of blood pressure records could establish the prognostic value of a novel blood pressure index. So thank you very much for your attention.